This section is on ellipses, which is essentially a version of a circle. What we're going to do is we're going to take that equation of a circle and we're going to divide it by the radius to get the equation here. So you will want to have your formula sheet out because we will be doing some new formulas here. So make sure to have that with you. So here's some definitions. An ellipse is just the set of all points in a plane such that the sum of the distances are from two fixed points is constant. Instead of us having the radius, we have two fixed points that we're kind of rotating around, and those are called the foci. So we have two axes here. One is called the major axis. The other one's called the minor axis. So they're going to be perpendicular to one another, and we'll see here as we go throughout this kind of how that works and which ones are which. But the major axis are what the foci lie on. The minor axis goes perpendicular to that. And the center is just the intersection of those two axes. Alright, so the equations we're looking at, if it's centered at the origin, so if h and k are 0, then the standard form of the equation is x squared over a squared plus y squared over b squared is equal to 1. Or, if it opens vertically, it's y squared over a squared plus x squared over b squared is equal to 1. Foci you find by using c, and I'll show you how to find c here in a little bit. The length of the major axis is 2a for both, and the length of the minor axis is 2b. So you use that from the original equation by finding a and b, and then that's how you find the length of it. So again, we'll get to that as well. Alright, so they want us to write an equation for this ellipse. So it's a little off because I tried to computerize the ellipse, so it's not exactly, it should cross those points on the top and bottom right at the point, not just slightly above and slightly below. So as we're looking at this, we want to write an equation for it. So we need to figure out, the major axis is the longer of the two axes, so you want to figure out, is it opening vertically or horizontally? So for this one, it is going vertically, because it's longer up and down than it is side to side. Excuse me. So looking at this, the major axis goes this way. So that's our major axis. This would be our minor axis. And again, that center is right here at the origin. So we want to count how many units this is. So it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 units. I'm sorry. I counted this one. I was like, this shouldn't be an odd number. So yeah, this one here, it goes 12 units. So 2a is the length of the major axis, and that's 12. So if we find a, we find a to be 6. The length of the minor axis, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So then 2b is equal to 10, which means that b is equal to 5. So again, we're centered at the origin, which means we just have x squared over it should be y squared because we're opening vertically. So y squared over a squared, which would be 36, plus x squared over b squared, which is 25, and it's always equal to 1. So that's the equation of this particular ellipse. This is y squared over 36 plus x squared over 25. Alright, so they want us to find the coordinates of the center and the foci here. So this is where we're going to have to find out what is that c value. And I'll show you the equation we're going to use for that as well, because there will be another equation for that that you can jot down. Alright, so finding the coordinates of the center. Well, if I have the x squared over 16 plus y squared over 4 is equal to 1, that x and y squared, whatever's added and subtracted to it is our a and our b, or the center. So here the center is still at 0, 0. We haven't moved away from that yet. And the foci. So here we have the a is always first, so we have a squared is 16, so that means that a is equal to 4. B squared is 4, which means that b is equal to 2. So the length of the major axis, so we'll say major axis equals 2a, which is 2 times 4, so it's 8. And then the minor axis is equal to 2b, which is 2 times 2, which is 4. So here's a piece, these are 2 more pieces. Now that for that foci piece. The equation that we're going to have to use to find the coordinates of the foci, because remember it's just going to be 0, c, and, c0, negative c0. So to find that, we're going to use something similar to Pythagorean's theorem, except it's going to be c squared is equal to a squared minus b squared. So we subtract those two, so we have c squared is going to be equal to 16 minus 4, so we have c squared is equal to 12, so c is approximately, well actually we can use the exact value, c is equal to 2 square roots of 3. So then the foci coordinates, one of them is at c0, so it's 2 square roots of 3, 0. And the other one would be negative 2 square roots of 3, and 0. Alright, if it's not centered at the origin, so if it has a different center, here's the equations we're going to use. So it doesn't change much, we just add or subtract, we add or subtract something to the x and the y values. So just like we did with ellipse, or with parabola, just like we did with circles. And now we're going to do it with ellipses. So the only thing that changes are the standard form, and then the value of the foci changes with the h and the k. Alright, so now this time, again, this is going back to that equation I told you when we did circles that we're going to have to do with all these different things. So we're going to have to find the standard form of the equation and then do all of those things. So we're going to group them. X squared plus 4x, leave some space, plus 4y squared minus 24y, leave some space, is equal to a negative 24. So this one, we can just rewrite x squared plus 4x. The other one, we have to factor out a 4. So we're going to say plus 4 times y squared minus 6y. So you go to negative 24. Complete the square. 4 divided by 2 is 2. 2 squared. We add 4 here, so we're going to add 4 over here. Negative 6 divided by 2 is negative 3. Squared is 9. So I'm going to add 9 in here, which if I add 9, that means I'm really adding 36. So then we'll add 36 over here. We factor, so we get x plus 2, the quantity squared, plus 4 times y minus 3, the quantity squared, is equal to a positive 16. Now we're not done yet. This looks similar to the one that we did with a circle, but with an ellipse, this always has to be 1. Okay, so you have to divide by 16 to make it 1. And that means I have to divide all pieces by 16, and this is where the denominator comes in. So now our actual equation is going to be x plus 2, the quantity squared, over 16, plus, now that 4 and the 16 will cancel to make it y minus 3 squared all over 4, and that's all equal to 1. So then a squared is equal to 16, which means that a is equal to 4. b squared is equal to 4, which means b is equal to 2. So they want the coordinate to the center. So our center is at -2, +3. It says, and the foci, so we have to use these values to find c. So we take 16 minus 4 is equal to c squared. So again, c is going to be equal to that 2 square roots of 3. So we have our foci. Now this time we have to take this and add it. So we're going to take -2 plus 2 square roots of 3 and the k value. So all you're doing is taking the center and adding this to both x values. Or the other one would be -2 minus 2 square roots of 3 and 3. So this is a piece. This is a piece. The lengths of the major and minor axes. So the major axis here is 2a, which will be 8. And the minor length is 2b, which is 4. So there's a lot there, but once you find that initial equation, the a and the b value are the ones that give you a lot of that. Because then you use that to find c, and that helps you find the foci. And there's your homework. So that is the extent of this. So again, not super hard, not a lot more, just different equations, and we're finding different things. So your equation up there is, or your homework is 586, 9 through 25 odd.